Okay, before the break, we were taking a first look at Unity Engine. There's a lot going on there. It can be overwhelming. You want to take some time to click around and do stuff. That's the best way to learn, is just start doing stuff. So I want to try to, I threw a couple random pieces in there to point at things. So I want to try to start making a small example with the rest of our, I guess not the rest of our class period, the next few minutes. And then there's a whole bunch of time in our class period where you can click around on things, and I'm ready to answer questions. I would say they're ready to answer questions about to get started. So I closed that one from before the break. And I guess I could point at one thing real quick here. So here's where I made that new project. I think it was this one. And look at how big that is already. We didn't really do anything in there. The properties say, I go to properties, will it say how many files are in that folder? Yeah. Look at how many files there are. And we haven't really done much. We didn't add very many files there. These projects are really, really large. So for one, it's going to be way over the upload size to get to GitHub. You'll have to use a command terminal to get to GitHub. The GUI or the web interface is 100. There's file limits. It's 100 files on the web interface. You can do a couple thousand with the Git GUI, the local desktop version of the GitHub repository web interface. But 22,844, if you want to put that in a repository, you kind of have to use the command prompt. So we'll look at how to do that here shortly, or at the end of the day. But there's a lot going on in the game. But the installer finished, so you can see now I have 2 different versions of Unity installed. So that's why we have to use the hub, because we have different versions of the game engine running. And then that's back to that note at the beginning of the day. Don't switch engines in the middle of a project. Once you start working with a particular engine, you need to keep working. You need to stick with that engine. And you will get little message boxes pop-ups asking if you want to update. Just make sure you don't. Otherwise, you'll have to restart any project that's in progress. So this is the one you all should have. That's the latest long-term support. I'm looking at the list. This latest one, that's all. I've been expecting at least one number since then. I thought they did at least one release, but the thing with 2022 on it still says beta release. So maybe they found more bugs than they expected and haven't moved into long-term support yet. But make sure you grab a long-term support, especially just getting started on. We'll go to projects, and I'll create a new project. Again, 2D at first, and then we'll look at 3D the last couple of weeks. They have a lot of similarities. It's a time difference, really, but it's not like 1/3 more. It extends up by plane. So 2D gives us 2 dimensions gives us 1 plane. The 3 dimensions gives us 3 planes. We have the XY plane, the XZ plane, and the YZ plane. So it's 2D is only 1/3 of 3D. Otherwise, it just scales up to more dimensions. But it scales up more than you would expect because it goes up by the plane, not by the axis. And we only count the axes. So choose 2D and keep an eye on up here at the top. You'll see you can choose which editor to use. This is the newer one. So yeah, the latest one installed. And this will be Smiley Dragon game. Because drew a smiley face and tried to download a little dragon from the asset store. I don't know what happened with it, but hopefully it's there now after restarting. It could have been because everything was changing since I was downloading a new engine while that was happening. But I know I should have those two images around so quickly do it. Quickly put something together with them. Maybe smiley faces come bouncing across the screen and the dragon has to jump to avoid them. That might work. I guess that would have worked on without restarting a new thing. So what we had just a moment ago would have made it good. A good start for that. And then waiting. It's a new project. So those 22,000 files I just pointed out, those all we have to wait for those to compile for the first steps in the new project. And sometimes it takes a minute or two. So there is a lot of waiting. Even once it's going, we still have to periodically wait on the compiler. We'll make changes, and then a change we made turns out that every script in the game has to recompile.
I have a question.
Yeah.
In terms of the hierarchy, you're saying you could develop a scene hierarchy with a branching tree schema.
Mhm.
So a parent or a child can only have one parent. Is that? So I'm saying, can you branch off and then merge back, or
you cannot merge back.
So every path necessarily reaches permanence.
Yes.
Right. So that if you want to go back, you have to go back up through that branch.
Yes.
To the bifurcation.
That would be a graph based. Have you seen those? Let me draw a picture. So an alternative data structure would be a graph where we have our nodes and just any connection, we can make sort of any connection between them. So we have lots of different nodes, but instead of like a tree, we can come back together and bring it back to where it came from. And there's lots of different connections. So like the fully connected version would be like that. The JMonkey engine has that. It's a graph-based hierarchy, graph-based scene. But in Unity, it's the hierarchical structure. Usually we save tree for when it's some sort of binary tree or balanced tree. The hierarchy, we're stuck with just the hierarchy. So we can keep going, but every path does eventually terminate.
And so I guess in terms of if you're laying out a physical model, you would have to retrace your steps to start on a different path.
That's one way to think about it, yes. Yes, but it does, the hierarchy, as far, the hierarchy doesn't necessarily have to, it doesn't need to match what's in the scene. This is sort of data and this is what we're viewing it. But you'll see the sample scene is at the top, so that's the root node. And then we put a bunch of stuff in there and then we put children of those and children of those. There's a chain of parents going back up, but they do all terminate somewhere. Okay, let's see if I can grab that dragon asset back. We'll go to Window, Package Manager, and My Assets. Okay, at least the sign in button did something this time. There we go. earlier, I wouldn't do anything, but there's all the stuff that I've grabbed from the Unity store over the years. So like backgrounds and characters, tile set for a cave, visual scripting, but that is built right in now. I have several playlists for this on my YouTube channel. I can get you if anybody wants to cover visual scripting. A couple years ago, we did a statewide event, like a game jam event. Things were virtual and try to bring people together. And we spent a afternoon making games, and I did the tutorials for it using visual scripting for Unity. So I have that whole playlist, so it walks all the way through a small game. I think 15 videos, but it was made to be done in like one afternoon. Split up in teams of 3 and then spent the afternoon making games. Oh, there's the dragon one, so we're gonna go ahead and grab that. I'll hit download. And then once it's there, there's a new button for importing it. And that will import it into the project. You can see a whole bunch of checkboxes and things like which one you want, all the things that go with it. I'll just go ahead and import all of them. Hopefully it's organized nicely. You all saw where I just found that on the thing. Okay, it's at least in one folder. Oh, this one does look like it's got some nice stuff. So a demo scene that it came with. What's that demo scene look like? Okay, not much of a demo scene. Let me go back to the sample scene. Go back to just the blank one. And then their assets, and that dragon folder. Just a bunch of images, some different animations. See, it looks like everything, they're all separate images, so all the images for the animations. We'll look at the animation thing soon. For today, I'm just going to bring one image in, and that'll be our one we control. So our character will start somewhere like that. And then we'll put a platform where you can jump up and down. And looks like there's fire, so maybe breathe fire at that's the push of a button. Jump up and down, breathe fire, push of a button. That'll probably take us till about 5 after 3 or so. It's after 3. So then it's like we saw before. Right over here, right now it just says that. So I want to change dragging that in there. Let me use the hierarchical structure. Because one thing we always want to do is separate our logic and graphics. So I'm going to hit delete. I'm going to use that same picture probably. I grabbed it randomly, so I might grab a different one, but if, we could think of it as the same picture still if I grab a different one randomly in 2 seconds. And over here in the hierarchy, if we right click, here's the different things we can create. It's like 2D objects, set up triangles and squares and our basic 2D shapes to start drawing stuff. Different sort of effects that we could have. Streams and fields. So physics, sort of a wind field, so that everything kind of blows over to one side and we put it in that place. Think of it that way. A lot of it, UI panels, so like buttons and input boxes and all that stuff, build up the HUD. Or if anybody's taking the 248 class with me in the spring, we spend our first 2 weeks building regular C# applications in Unity and just use that to learn how to make a HUD and the syntax for C# so that we can get into the game making. Because we got to learn a HUD for our game at some point anyway. So it just made sense to just practice C# that way and just make regular applications. Like you see in intro programming classes to get the syntax, right? A tip calculator and a sales tax. Calculate sales tax and those small, simple things to get the syntax before we get into hard games. But that's the next class. You also notice the very top of this list is just create empty. So that's an empty game object. So I'm gonna create an empty game object and I'm gonna call this player. So that's our player. And notice the player has transform data, which I have no idea why that's not 0, 0, 0. I'm gonna reset the transform data. But it doesn't have any other components yet. And I'm gonna make that image a child. I think it was this one. So I'm gonna drag it over here, but instead of just putting it in the hierarchy down below, I'm gonna click and drag till the player's highlighted so that it's a child of that empty object. So our logic, the script and everything goes with that player object. And at some point later, if we went, oh, I meant to make that, I meant to use this image, crouch 3, not attack 1. We can switch that image out and nothing changes. That's kind of important, right? Because we're going to work with those testing images while the art department gets a really nice version. And in the end, we want to be able to just swap it out for that nice graphics. So always separate your logic from your graphics. Make 2 sort of rendering pipelines. So the parent object has all the logic, and the graphics are just a child that comes along with it, with whatever that logic is doing. Then we can put our scripts and everything there. And if I say go 1 in the X direction, I'll click on the child and I set the transform data 1 in the X direction. But now if I go back to that player and maybe say -3 in the Y direction, notice the child is still 1 unit to the left. So the child transform is relative to the parent transform. You have multiple transforms to keep track of, basically. So be careful with those. Always try to work on the parent as much as possible. Make sure you're the right one selected. You can select it here, but it's kind of hard to. All you can click on here is the graphics. So it's best to come over and make sure. Always get in the habit of always going to the hierarchy first to make sure you have the right thing selected. So we have our player object, and this I will rename as player image. And that's the one we want to remove or move around and do stuff with. But we're going to do it with the parent object. I need to add some physics. That way gravity will take over and it'll fall down and stand on some ground like we saw a moment ago. So I'm going to go to the parent object, add a component, get zoom buttons out of the way, and need some physics. So I'm going to add a rigid body component, and it does need to be rigid body 2D. 2D and 3D are different. We're using the same Unity editor. It's going to look like a very similar Unity editor, but Unity has 2 game engines, a 2D engine and a 3D engine, and they are not exactly compatible. Can I pull up some arrows? I select the graphics and hit the arrows. So we can see they go from the positive X to the positive Y is a counterclockwise rotation. In Unity 3D, that would be a clockwise rotation. So they are not compatible. So always make sure you're using the appropriate one, whether 2D or 3D for what you're working on. So that gets us the laws of physics. They'll start falling down. But like we saw before, we also need a boundary. We need to define a boundary. Where's the edge of this? And notice that I'm putting this on that parent player object. So when I add a component, what's that in a 2D box collider. Notice where it put the image versus the one where it should actually be. Oh, and when something's highlighted, you can just push F to give it the main focus on the thing. Is that child object too low or something? Well, it says it's centered at the right thing. So if we go back to the player object and then click this edit collider button, you might want to adjust that so that it looks appropriate for your image. As we can see it a little bit better here this time. It was hard to see that green box when it was in front of something white. But that gets make sure that's set up correctly. And our graphics are separate than our logic. We'll do all the testing here, and our department will give us really good graphics later. Make sure you give your sizes to the art department. That way you don't have to come back to it and resize everything. Test with the correct size and then tell the art department exactly the size you need and everything. Then all you have to do is quickly swap out the files when they get to the good images. So I'll scroll back out to Zoom. I'm coming up to the assets and add in a background. Or maybe I'll go to, let's see, if I go to, oh, not the asset store. If I go back to the package manager, I can see other backgrounds in package manager. When this is set to over in the top left, right next to the plus sign, you click on the plus sign, you'll see some strange looking things. Right next to it, it's set to my assets. So here's the stuff I've already downloaded. What sort of backgrounds do I have? Oh, this looks like it might have a nice background. So I'll grab the background from this one. I see something bluish there. So I'll download that and import that. And I'll just import everything. All I really want is the background, but this is a small beginning thing, so it's not going to have those extra things in there. And something we've seen a few times already, lots of waiting. That hopefully has some platforms too. And then we can make our dragon stand on a platform instead of that crown. That very, very quick thing I drew earlier. Whenever I grab the crown tool in Microsoft Paint, that's for a very, very quick image. I'm going to be deleted next time I get over to the delete folder. But it worked for its purpose. Look at this ninja spreadsheet. I kind of want to bring in the ninja with the, yeah, I only wanted to go till about 5 after 3 or so. But maybe there's time to throw a ninja in there and start towards some sort of ninja dragon. And I can come up with all sorts of ideas for a story that would involve both ninjas and dragons. All sorts of fun things. But we have the asset store where there's professional. It's a place where artists regularly sell their work. And they often have free work because check the readmes. They will all have readmes on the Unity asset store. And most of the free stuff, they just want credit. So their artists, they'll be very specific. They'll tell you what font to use when you give them credit in your game. That sort of thing. Did I hit import on the Ninja one? I don't think I did. I think I just downloaded. Probably not getting all the way to that, but I think it's a few different assets in there instead of the super quick drawn ones. From a couple of different packages. There's lots of options on the asset store. But you can see we get it right here. We have to go to the browser to shop around, but we add it to my assets and then we grab the my assets are right there in our project. ninja files. Ping. And again, I don't know, it's probably going nowhere, so I'm just gonna make I'll create an empty. So again, right click, create empty. Right now it only has transform data. This one doesn't need to be here. And then I'll give this one of the ninja images as a child. 0, 0, 0. Which you'll notice all of those images seem to be facing the same direction. I mentioned earlier, way back when we were talking about Pygame, how to do that. A lot of engines, they built in a flip method. But a flip is really, they didn't put one in Unity because it's really only one line. So that method's not saving as much trouble. And logically, what we're doing is negative 100% scale. So on X, and if we start making X smaller, so we go from 1 to 0.5, and then squishes down. 0.1, it squishes down even more. But then when we cross 0 and go to negative 0.1, it flips over across the axis. 0.5, stretch it back out. So negative 1 is like negative 100%. That just flips us across that axis. I shouldn't say across, because if we were dealing across, we would be adjusting the Y value, right? When we, at negative 100% on the X is a mirror image across the Y. We flip across that axis. So to flip your image, most of the stuff you find on the asset store to keep the packages somewhat small, we don't need to duplicate every image, right? We don't need to have it like facing right and facing left. So you'll have one or the other and just do that negative scale, which is also really, really easy to do from your script. Just change it. And if we push the A key, switch to scale X on -1. And if we push the B key, switch to scale X of +1. And then the image is always facing the right direction for which way our character is moving. And making assets. Never seen 3D platform assets. Let's see, chest, there's background. New background. Okay. A whole bunch of folders here. Okay, there we go. Eventually we get down to a background. So I'll just drag that in there. The background's never going to do anything except sit there. So what I like to do is usually just grab it and resize it, which we can do from the numbers. So 0, 0, 0, right in the middle. And this is one place where layers come in. So this is the wet key thing right here. The Photoshop layers. We just find which layer is where. That's the visibility layers. And we can set some further back and some further up. What I usually do is just use the Z-axis. So we'll look at layers soon. So for a quick introduction, we do have a Z-axis. We go to our camera. We see our camera is at -10. So -10 is like out of the screen. The other direction must be into the screen. So for backgrounds, I think it's a lot easier just to use, instead of intermingling 3 different types of layers, I replace visibility layers with just the Z coordinate and then only have to deal with the interaction layers. And it's less, the interaction layers and the masking layers. And then it's less confusing as to what is meant when we say layer. So we'll talk about them at some point, but and so if we set that as +10, then the background is way back there, and then our characters are both around 0. we could adjust it to like 1 or 2, or in your script, you could make little wavements there, adjustments as far as which one passes in front of the other one. Right, it's a simple selection structure. We got the ninja. Got the move tool. So if the ninja Y coordinate is a little lower than the other one, we would want that to pass in front, right? But if the ninja Y coordinate's higher, we would want it passing behind the other character. But that's a little simple selection structure. Which Y coordinate's higher? And the one with the higher Y coordinate is drawn in front of the other one. You can't do that with the layers. That's the big thing I like about using the Z axis, the visibility layers, is we still have control and we can adjust where it is on that axis. There's our characters, and we need some sort of platform, which I'm guessing this one was called free platform stuff. So I'm guessing there's a platform here somewhere. Background, character, chest, coin, animals, enemies, environment, probably environment. Oh, that looks like trees and flowers and stuff. Oh, no, I don't need that. Okay, there's the platform. I'm just gonna grab one of them. Actually, I'm not gonna do that yet. Delete that. I'm gonna right click and create a new empty again and call this platform. And then once again, I'll just bring one of those platform images in. I'm gonna scale that down a little just because of how it looks next to our characters. The background looks a little bit big for them, so maybe 0.5, 0.5, there we go. Slightly smaller one. Maybe stretch it out on the X. 1.5. Whoops. 1.5. There we go. So that'll be our platform size. We can set a bunch of them around, set up our laws of physics. I'm going to move it back to 0, 0, 0 as far as the parent goes, and then move the parent to where this one needs to be. So I'll move the parent maybe somewhere over here. Our first platform, and we need some sort of bounding box so that when our character or the mob falls down and hits that platform, gravity will stop falling, right? And that's our rule. At least one of the items has to have the laws of physics. One needs a rigid body, and both need a boundary. So both things involved in the collision need a boundary, but if both things had the laws of physics, it sometimes gets a little wonky. Because if that just has a boundary, our character is going to come down and interact and stop moving. But if it comes down and that platform also has the laws of physics, then there's balance and friction and all sorts of funny things might start happening. If we fall on this corner of the platform, it would be different than if we fall in the middle when the platform has physics applied. And I'll use a marker. What happens when our marker falls and hits the floor? I can't really see it. Maybe I can drop it on my the thing. You can see it. It doesn't just stop moving, right? It bounced around and kept going. So if we have physics applied to both items in the collision, wonky stuff like that starts to happen. So you want to try to only have physics on one of your items. Sometimes it's unavoidable. And when you have to have it on both, then you have to start dealing start cleaning up strange things that you may not have predicted or anticipated happening there. But our platform needs a border, so I'll add box glider, and not quite the right size. So buttons do different places depending on where your mouse is. I want to focus on that. So here with my mouse in the scene area, if I push F, it'll bring focus to just the thing that's selected, the platform. And on the platform box collider, there's this button to edit the shape of that collider and just drag that out so that it matches the platform. Okay, right at the top, or should the top of the collision be somewhere in the middle of the thing? I'm thinking somewhere in the middle, and that way it looks like we're kind of looking down at our character and we can see a little bit of grass behind and in front of them. Different ways they could be handled. I definitely want my player to be in front of that. So the player's at 0, 0, so I'll move this back 1. That way that'll ensure the player and the mob are always in front of the platform. And we're going to go over this stuff more than once. I just wanted to make up some stuff here, the first example. So now, does our player have physics yet? Yep, has physics. He's going to fall down. When he hits the platform, he's going to stop falling. The platform's not under him. Now the platform's under him. He should fall and hit that platform. This guy will also need a rigid body. So I'll search for rigid body 2D. Give him laws of physics so he starts falling down. Oh, whoops, I put that in the wrong spot. Make sure it goes to the parent object. So add the laws of physics. And then add a box collider. And make sure the collision appears like it's going to happen in the right spot for that character. I'll skip his sword, because otherwise it seems to fill in the thing nicely, and then that way, at a point later that we're not going to get to today, it might look like the sword goes through something before the collision occurs. Be nice for the animation. So he's going to start falling down, but there's nothing for him to hit, but we can just duplicate that platform and duplicate a bunch of platforms. So if you push Control D is duplicate. So notice now we have another platform 1 over here that inherited the same image. It's an exact copy of the other one, so it has the same image and everything. I'm turning on the little arrows so I can just kind of move that over somewhere, and there's where that character starts. And Control D will duplicate. Now we got another one. I'll bring this over in the middle, maybe. Control D. Keep duplicating our platforms, but still make it where the character can fall and I guess fall into nothingness from our fight scene here. All right, we got a few platforms. Can probably give it a test run. So I'll hit normal Control S to save. And there are lots and lots of files, but they didn't give you a regular save. It's labeled as save, but it is a save all that you're probably used to from your other writing code elsewhere. Usually lots of files involved. So if we hit save, it causes problems. We always want to hit save all. In Unity, they just got rid of the save button. So the only button we have is a save all, which makes a lot of sense. I don't know why more IDEs don't do that, because the save button just messes things up. So we go, so our characters fall down and land on that, because we need to jump and move. We're gonna do that in a script. So, quick passage of script. I was hoping to be here about 5 minutes ago, so I guess I'll do a jump. They're all kind of the same. So when we went to edit in project settings, under the input manager, there's some axes, the preset controls, the things we expect a controller to have. And if something wants to be a plug and play controller, it better have these things. That's an HID report. That's already knows is a different world altogether. It's really, really fun to write them. You basically have to write them in port manipulation. The closer you can get to machine language, the better it's going to be. But I think it's really, really fun. Somewhat fun. It's one of those projects that you're probably going to throw your stuff screen cuss words at some point along the way because you're trying to write and manually control what is in each register without using any high level programming language keywords. Means a one goes to the third bit in a particular register, and that's the options of how you can write the code. Kind of fun thinking about the machine level, but it's also frustrating. But all the stuff better have those things. So we can use the horizontal axis to move left and right, already set for our A and D keys. And the jump axis will get our space bar. Oh wait, no, that's not space bar. Jump joystick button 3. Which one's space bar? Am I looking at the wrong thing? Oh, okay. Oh, there's enough for 2 controllers. Gotta have it set up for 2 controllers. So our player 1 space bar is the jump controller. And the horizontal axis is the A and D keys. So we can make use of those in our script. We'll need to edit them. And that is, what is it on here? Graphic performance audio editor. Edit. So just a few minutes ago, I said I recommended not installing that Visual Studio. So Unity probably doesn't know what text editors use when we create a script. And I'm suddenly drawing a blank on where that's at in the menu. There are a lot of menus to dig through here. Timeline. Pretty control. Wasn't that I'm your editor? Unity, SS stabilization. I was here. Preferences. Oh, there it is. So under preferences, sorry, I was looking at the wrong menu. That's why I couldn't find it. So under edit and preferences, under external tools, you want to choose the tool that you will edit your text file with, your C# script. I'm going to use the Sublime text editor, but some text editor that you have on your computer. You'll probably need a regular text editor. For now, you can probably go to Notepad++. Notepad, if you don't have anything, Notepad++ will work. You want to find a good text editor. If you don't have one in mind, find a good text editor instead of linking to another IDE. Because that's the problem with the visuals. with Visual Studio, if you use a full IDE to edit your script, it's going to use the Microsoft compiler for C#. But we don't need the Microsoft compiler for C#. We need our C# to be compiled as C++ code. So we actually need a GNU compiler, not a Microsoft compiler. So if we use an IDE, if you use a regular IDE, you'll have to wait for everything to compile twice. And you've noticed that when we're ready to run is not the only time we have to wait for the compiler. We've seen it run several times already, right? It's like packages are updating and all that. That's waiting on a compiler. So you don't want to automatically double all of that waiting time. Even if you have a really, really impressive gaming computer, right? And you got 64 gig, there's a processor in front of you. You still don't want to double your waiting time if you can help it. So we just need a text editor. So on external script editor, just choose where it is, go to browse and navigate to the particular, the exe file, the actual application. So it's probably in program files x86, program files 86. Or if you're on a Mac, it's right in the application folder. Go to your applications and keep going when you get to the icon tab. The thing that shows the icon in the applications folder is still a folder. You don't click on it to start, but if you long click on it, you can navigate into it as a folder. So keep going until you hit the actual application itself. But just point at the text editor. And then when we want to add a script, like we're getting very short on time, I want you to be able to start clicking around. I guess we'll just jump real quick and look at the first version of this. It's not really jumping between platforms, but when we hit the ground, we can jump upward when we hit spacebar. So we need to add a new component, because just like all of this stuff, what these are that we see in our inspector, those are actually pre-written scripts. Yeah. So go to the top level one, the player, not the graphics, not the image of the player itself, and click add component, and it is perfectly locked on the TVs here in the classroom. And add component, only this time we can't use a pre-written script because we need to make our own. I'm going to call it player. So this will be our player script. And you see the option from the fuzzy finder. There's a couple things that have player in them, but there's also a new script button. So let's make a new component altogether called player. And new script, and we'll create an add tag. And we have to wait for it to run, and it's probably up at the top. Thanks. So over here in the project explorer, if I go all the way back up to assets, you'll see we have this player script to show up. We can add new functionality that wasn't already built into our thing. We open this, and it's kind of started out for us. Our scripts will always look like this. There's different ways we can write our curly brace. Some years ago, somebody actually took the time to ask 10,000 programmers, what's the easiest way to read the curly braces? And 10,000 programmers that answered that survey, the majority said like this: the opening curly brace on the same line as the keywords, indent everything in between the curly braces. Because if we have curly braces and semicolons, the white space is only for the programmer's benefit. That gets deleted when it compiles. Opening curly brace with the keywords, indent everything, and then put the closing curly brace lined up with the keywords down below. And for good measure, it doesn't hurt to go ahead and throw a comment on your closing curly brace, because the opening one is always right next to keywords. That's easy to spot. But you're closing curly braces, it's really easy to lose track of those. And we always have these two methods in Unity. So C# is object oriented only. So we have to create a new class. And this is the end of the class. Just, it can be useful to have those labels on there so we don't get lost in it. I can't quite get everything I was wanting on the screen there. There we go. There's some stuff being imported up above. Our keyword for importing in C#, import include, is using. So using the systems.collections library, or using the systems.collections.generic. It's actually namespace in this case. We have lots of words we call the same thing. There's more than one of them, so it's more than one of them, and we are explicitly in the C family, so it's a namespace, not a library or a package or a module, but pre-written code. So we import those, and then we create a new public class, give it a name, and everything in Unity inherits from mono behavior class. Mono behavior, think about what those words mean, does one thing basically, right? One action. And you do have to inherit from that in order to do anything. And then we have two methods that we need to work with, start and update. Start runs one time when the game initializes, or when the object first shows up on the screen, we have an initialization, and update runs every frame of the game. And so all of your setup stuff, and then every frame of the game, basically. There's different ways we can move our character. What I'm going to do is I'll use the physics to move it today. We gave our character a rigid body component. So here in our script, we could grab rigid body 2D sort of data. And if I come back over here real quick and click on the character, notice how it's spelled. Rigid has a capital R, and B is lowercase, and then the space, it just automatically puts those so it's easy to read here. There are no spaces in data types. I think everybody already is probably aware of that. So a rigid body 2, and it looks like the D is capitalized. So I'm going to call that body, and then that will get a reference to that rigid body, which is our actual law, our actual physics, the thing that controls the physics of the game. And what we're going to do over and over and over again in our initialize, where we initialize it in the start method, we're going to make the assignment of that by calling this get component method. We'll do this over and over and over again. Switch back over here to Unity Editor real quick. Over here in the inspector, we have all these things that we're working with, all the stuff about our game. And down at the bottom, we can see it most clearly. Our button to add a new one is add component. So to get any of this stuff into our script, we need to get the component. And there's lots of different types of components. So this means generics. Some of y'all may not have seen that yet. It's a strictly typed language. We always have to pay precise attention to the type of data we're working with. And when they made the get component method, they had no idea what type of data we were going to use that on. They didn't want to make one for a rigid body, and another one for a material renderer, and another one for a script that we weren't going to write for 15 years after they wrote the get component method. So they had to use what was called generics, and they wrote it with a placeholder. But now that we know for certain which component we want to get, we can fill in that generic placeholder. So in angle brackets, we have to say what our data type is. It's a big change from Python. I know everybody's seen some Python was on a couple weeks ago. That's open type. We don't have to say what type of data it is, and the computer figures it out, but that takes time. We know what type of data it is, so when the computer doesn't have to waste time figuring out what the data is, and then waste more time every frame of the game figuring out what that data type is over and over and over again, it's going to be a whole lot quicker. There's huge advantages to the strictly typed things, but we always have to write what it is. And we want some rigid body 2D data. And then this is a method, so some parentheses, because it's something we're doing. And then a semicolon means end of instruction. Technicality, once that processes into machine language, what the computer runs is very different than what we write in the text file. And technically, semicolon means next instruction. But from the way we write our text file, okay, so that technicality was that semicolon means next instruction. But because of how we write our text file and where it goes in the text file, we say end of instruction because it makes a whole lot more sense. We put it at the end of the line. So body is assigned the return from this get component method. That should look familiar no matter what language we're working in, right? And we're in C family, so end of instruction. We don't leave the computer to figure out when the end of instruction is on its own, because that wastes time that we don't want to take away from our game. We want our game to run as fast as it possibly can. And we know where the instruction ends. We don't need to just save one key press so the computer can figure it out on its own. So now that we have that body component, we can do things with it. We can check our input values. So I'll set that up and do a quick jump. Barring any typos, just talking about C# today. So I want to wrap this up so y'all can kind of start clicking around, but I wanted to do the first couple steps of this. Right? This is preview on C#. I did not expect you to know C# after the first couple lines I've typed here. We need to grab something from our axes. And it's actually a floating point number that the controller gives us. So we need a floating point type of data. And it varies on this. I'm just going to do the jump for now. So jump goes somewhere between 0 and 1. And the reason it's a float and not a double is floats are 32 bits smaller. 32 bits, the default on Unity should be 140 frames per second. 32 bits, we're saying 140 times a second. And our game's probably going to run for many, many seconds, right? That's a lot of bits that we're saving. That adds up into faster processing. Usually, business settings, we usually go with doubles and stick with it. But saving that 32 bits does still show up for game developers. So almost everything in game dev is going to be a float, not a double. A float, and this will be, I'm going to call it vertical. I usually use VER and HOR for horizontal and vertical. Hopefully an obvious abbreviation. I'll probably use it a lot this semester without even thinking about it. And that is going to be something from our input axis. So we can call this method get input. So then I want get input or get input axis. I'll try input. Maybe I do one axis. Get input axis. And And then over here, when we looked at the project settings, our input manager has these axes. And we, in particular, we want the jump axes. Axes are another word for dimension. So it's a vector. Input manager has a vector, represents our controls. And one of the dimensions is the jump dimension, or horizontal dimension, or vertical dimension. Vertical and there's multiple parts to a vertical and horizontal dimension, right? We have left and right. So it breaks down lots of different ways, but you can think of it as dimensions in a vector. So we need to grab the input manager and get the axes from that. Maybe that's the one I wanted to type. So I want to look at the input manager for the system. And that input manager should have a get access method. And I just pulled up the list to see how it was spelled. Then the name from that axis, which happens to be jump with a capital J, is set to our space bar. So when we push the space bar, if we don't push the space bar, it's 0. And if we do push the space bar, it slowly increases up to 1. Depending on your system, you might have a better space bar and be able to control, you might be able to push your space bar halfway down and get a 50% on it or something like that. But those keyboards are very, very expensive. At the very least, on a cheap laptop like mine, I at least have 0 and 1, not pushed or pushed. So then we can check those. Let's see, if that vertical value is greater than 0.5, then I want to take the body and there's several different aspects of that rigid body. As transform data, velocity, I'll use velocity. Body dot velocity dot y, and then I can just change this, which actually I can't just change this, but let's set it to like say 7. This is going to throw an error. It's not going to like this at all. I'll set it to 7. So then it goes up and then gravity takes over and it should come back down. Pull it back down to negative numbers. Then after that upward velocity, it's going to try to come back down. It's not going to like this. And I want to look at where error messages show up. So I'm going to hit save. Go ahead and save that. And then we're not allowed to do individual assignment to a vector dimension like this. But I wanted to point out where error messages show up. So come back over here and the compiler ran, and you'll see that there's that red message there at the bottom. Asset player error, tells us where it's at. Right behind the project window, at least in the default view, you should see the console tab. Here's where your error messages go. The name input manager does not exist in the current context. Maybe I don't need input manager. Maybe I just need to get axes. Let's see if that works. And get access does not work in the current context. You got a typo there. And this one cannot modify the return value of rigid body 2D velocity because it is not a variable. So we can't change that. So what we have to do is it works as a vector, and I'm drawing a blank on what to maybe it's input. I get access. I might have to double check what the word is for that here in just a second. But this one, velocity is a full vector. We have a number, the speed, a speed and a direction. So how much are we moving in each one of our axes? Which to jump, we need a positive y number, because that would be upward in the y value. But we need to keep track of our entire two-dimensional vector. So body dot velocity is going to be reassigned a new vector 2. So in 2 dimensions, there's also vector 3. That's the ones we'll be using this semester. But for 2D, we need a new vector 2, and then a vector 2 gets an x coordinate and a y coordinate. So if we want our jump to go straight up, our x is going to stay the same. So x is still 0. And these are always floating point numbers. So if it was a double, we put 0.0, that gives us a double. In the C family of languages, to make sure that it's floating point numbers, a 32-bit number instead of a 64-bit number, we do have to type an F there. Capital or lowercase, either one's fine. The 0 as a floating 32-bit floating point number, not a 64-bit floating point number. And then Y, we can do like 7.5 F. So then that'll start our velocity going straight upward. And before long, gravity is going to take over and slow that back down to 0. And then it'll pass 0 and go negative and start falling again. So sort of basic laws of physics on that one. And come back over here, save it, and then come back over here, and the compiler will run. Oh, I guess it was input. I was thinking, I couldn't remember the word, and I switched to just say input instead of input manager, and that error message went away. So preview on C#. Oh, and then don't forget the end of instruction character at the end of your line. So it looks like everything's going. If I run it, let's see what happens. So gravity took over, character went down, landed on the platform. If I push space, it jumps up. Gravity takes back over and it comes back down. I guess 7.5 was a little high there. Might as well move right and left. That way it's already going over what I was planning. And this is something we're going to do all the time. So we might want to go ahead and do both of them. I will show them right at the beginning for preview. Again, our input manager, which is just input. We don't need manager. But I forgot earlier, we don't need input. Is the input manager or anything else that has to do with it. We want to get access. And over here under edit, preferences, oh, sorry, not preferences, edit project settings. We have a horizontal axis and the name is horizontal with the capital H. So we can just ask for it by that name. We want the horizontal axis, and that is our A and D keys or whatever plug and play controller is set up. And then we can just check it this way. If horizontal is greater than 0, then we want our yeah, I'll just switch to velocity and maybe 0.2 and 0 vertical component. Else if, and we do have if else, and then in between, since the only language I know for certain everybody's seen is Python. Python can't have two-part keywords, so that normal one is jammed together into one word for the elif thing, but in C family, we do spell it out. So else if, and then a bunch of those, and at the end we have else. But the else part's trivial, right? Else doesn't need a condition. Just the keyword else, and then some curly braces put in those. If or is less than 0, body dot velocity is a new vector 2. This is not going to be very smooth movement. Of negative 2f, 0.0f. So if we push that button, we're going to go 0.2f a little bit to the right. We push the D key. A little bit to the left. We push the right, the A key, and otherwise I'm going to else. If we're not pushing the key, we'll just stop. I think, yeah, this is going to be some kind of funky movement. Not a very good one here. Usually we would change the velocity slowly, but this first day looking at C# syntax and stuff, I just want to look at basic movement and something that should look familiar, right? We can get some sort of event happening. Then we run a selection structure, and our game engine is just handling all the frames of the game. Along this set path of we have and something that happens when we initialize everything, initialize our stuff, and then we have the stuff that happens every frame of our game. Let's see if that moves the character left and right. Okay, setting that back to 0 is a problem. I made it fall slowly. Let me get rid of that else block. That was the one I was worried about. Except that, so without setting, and actually I want to change this just a little. So on this one, I don't want to mess up the current velocity. I don't want to go back to 0. I want to go to what the velocity currently is. Body.velocity.y. So I'm going to use the current y value. That's what I started typing at first. We can't reassign it, but we can read it. We can't change it by asking for it as a variable, but we can read it as a variable. And then we can just keep our y velocity the same, and our x velocity moves on its own. I guess when we jump, we should probably do the same thing, right? Let me put that in here. Except for the y, we'll leave our x velocity alone, and we're only changing the one we want to change. Let's see what happens. This is not going to be good movement. But it should move when I hit the keys. That's all I was looking for today. So if I jump, he goes up and comes back down. D, okay, 0.2 is really slow, but he is moving. Can y'all tell he's moving? Mine should have gone with like 2.0. And when I let go, he stops. Or I push it and go the other way. 0.2 is really slow. Let's increase that. 1.2. 1.2. And that's how much it moves each frame. So you want to be careful about how try a few numbers, find something that works. Okay, that's a little bit better. I'm gonna start moving over and jump up. and make it to the other platform. I can push this guy off the platform. There we go. I guess that means the player one, right? So we got a little bit of movement, a little bit wonky. If you were copying that exactly, you're probably having trouble moving that. I typed that forward for first example. Not the best way to move velocity. We would change velocity based off what it is. We control acceleration. That's Newtonian physics. That's right. In our car, we don't have a velocity pedal. We have an acceleration pedal. We control accelerations, that's how we apply them. So applying forces. So we shouldn't actually be changing velocity there. We should be changing acceleration, which is the change in velocity. But that's getting into Newtonian physics. But the basis of Newtonian physics, we should be changing acceleration, not changing velocity directly. But we can also just change the transform directly too. That works too. But our first passing entity got something on there moving. Hopefully those steps kind of make sense. You want to find a good text editor. I use the Sublime text editor. It's free to use forever. But there's a paid for version, but if you can use it free forever and just have the top that says unregistered version. It's like $100 license that's good forever. Like I'm a couple versions into that fairly inexpensive license, and it's good forever. But it's find a free text editor to use or whatever you want to use. Just remember, if you use something that has a compiler in it, it's going to have the Microsoft compiler, and you have to wait for everything to compile twice. Because we need a GNU compiler, not a Microsoft compiler. So basic first pass, you're going to want to click around, check things out. There's a lot of stuff going on here, and kind of like Blender, we don't even see most of our buttons. We have the option to even see most of our buttons is turned off right now. This is barely scratching the surface. It's a little overwhelming. The big thing is just don't get overwhelmed. It's game development. We saw about this last week, right? There's 7 things we do all the time, and then the other million things the game engine can do, we will use once a decade. So just try not to get lost in the stuff. We're going to look at it in a lot of detail. I want to do the first preview. Does anybody have any questions before we wrap up here? Okay, I assume the silence there means no questions. If you have any, let me know. What do we have? An hour and 10 minutes left in our class time to just kind of click around, look at Unity, see where the different things are, kind of try to familiarize yourself with it. Oh, wait, I need to show you something. We can't just put that on GitHub, right? I can't just immediately share that with you. I guess there is one more thing we need to look at. So that's it. That's finished. I can save it and try to get it to you all to look at for an example as you click around. But I'll go in here where it's saved. 1.79 gigabytes. That's way too big for. It's way too big for an email. I right click on it, check the properties. We had 26,479 files. That's way past the 100 file upload limit on GitHub. So we need to use the terminal to get it to GitHub. So I will open the PowerShell and navigate to this, where is that? So I go to my documents folder and the Unity folder. There it is. So Smiley, dragging game. Well, I'll go over to the delete folder. /delete. My normal working spot. There's a couple things in there, but that'll be fine. I'm gonna make a new folder called Git Stuff. And then navigate into that folder. And Git from GitHub is an instruction that goes in our terminal. So we'll use Git to initialize this folder as a repository. And dot is the way we refer to the current folder. So Git init or initialize dot means the current folder. So now that folder is a repository. And I need to grab our class examples. So Git remote add origin. In our class example, sorry, HTTPS, oops. So HTTPS protocol, // means protocol. So our regular web browsing protocol, go to github.com, Francis-Chris5, and then there's one on a repository on there called SDEV 148-fall 2022. And when we're actually using it here, we'd stop there in the browser, but here we actually need to type .git, that file extension that goes on the end of it. We got connected to it, so now I can say git full origin, the main branch, because I know there's only one branch on there. All right, that grabbed all the files from the repository. So if I grab this, copy it, and come over to the delete folder. So there's all the stuff that was already on the repository. I'll paste that in. And it's several gigabytes, so it's going to take a minute with the Unity project. Wait and wait and wait, and hopefully it won't take too long. And it's lots and lots and lots of really, really small files. So it can only go so fast, but it's a quarter of the way done, so it's moving along. But this is what we have to do if we have more than 100 files we need to upload. We just make a local version of it, and there's different ways. Most IDEs can automatically sync to GitHub, so you just work right from there. You don't have to download and upload. Or a lot of people prefer to keep a local branch of the repository going and just once a week or so upload their latest work. Whatever makes the most sense for you. As long as you have a local clone of your repository, you don't have the restrictions like file window sizes or anything. If you got 50 terabytes, you need to get up there and just have to pass in the instruction and give it time to upload 50 terabytes. It's almost done. It's probably useful to see these commands anyway, because this also works when you have one file and you're just starting into programming, and you feel way more awesome when you open up command prompt and throw your stuff on GitHub instead of going to a browser. Don't even bother to double check it or anything. Then you're sitting around coding, and it's like, okay, that's enough coding for today. Open up command prompt, throw it on GitHub, go get lunch. Feels more awesome than go navigating around, clicking our way through the browser. Almost there. 97, 98, 99. There we go. So now that that's copied over, I'll come back over to the command prompt and I'll say git again, our git command. This time add, and I'll say dot. So again, dot is the current folder, and recursion is implied with dot. So let's look through this folder and everything inside it, see what's different. And it's GitHub, so it's replacing all I made this on Windows machines, so there's carriage return line feeds. So it's going to go through, and while it looks to see what's there, it will also replace all of them. And there's a lot, so that actually this might take a second. Hopefully it won't take too long. Slowed down so much. Oh, wait. The scroll bar could go, it probably finished. There it goes. Okay, that's more like a normal speed. I'm not sure why it got so slow there for a while. But there's a lot of files there. We knew there was a lot of files, right? It's all text files, this programming. There's several gigabytes of text files. Luckily, we didn't have to write them all. Okay, there it is. So now it has examined it and to see what all changes are available, what is different than it was last time when it downloaded the repository, when it cloned the repository. So we can commit to those changes. We can git, commit, and then it needs a name. So -m for name or message, and then this is a first Unity example. Run that, and it'll go through and here very shortly should give us the actual number. So there are 27,250 new files that weren't there a minute ago. That's not the same number that File Explorer showed us. Okay, so now it's getting ready to write, getting all that written up, but that's the big one. You can see we don't have that 100 file limit anymore. We do it this way. We just uploaded 27,000 files, way more than that. So on the Unity projects, and if you wanted to put Game Maker on GitHub, you think your Game Maker project on GitHub, you probably have to do the same thing here. Come into the terminal and do it, where it's not restricted. And there's just one more command, but I think we should get there in a few seconds. I think it's the next thing that needs to run. So we don't need anything that's already on the repository, so just gonna delete all that. There we go. And now, when we get back to the prompt, we can say git, and to get a repository, we pulled the repository. So pull it down and push it back up. So git push the origin, and we are in the main branch. So when I hit enter, this will load that, send all those files back up to GitHub. So it's going to be a few seconds. Don't know how long an upload and download takes, how it takes upload and stuff. But that's the last of those commands. So here in a few seconds, that example will be on GitHub where you can download it and look at it as you click around and get familiar with Unity. I guess that took another 10 minutes. So we have an hour left of class. Any questions before we go ahead and wrap up here? I see head nods in the classroom here. I already asked that earlier. So I guess that'll be it for today. 58%, that should be there on GitHub in a few seconds. It won't be long. By the time you go get a cup of coffee, it'll be on GitHub. Otherwise, I will see you all on Wednesday, and we'll, that was preview mode. We'll go nice and slowly through a 2D game to see those tools again. Okay. So have a good one. I'll see you Wednesday.